Question 1, paper 1, 2017. It says, write this function, so we know it's a U-shaped function, in this form. This is just completing the square form. If you want to understand, I guess, where this form comes out of, you need to have some understanding of transformations of a function. So let's go to our basic x squared function, or the parent function. What if you wanted to move that up to? What would happen? Well, nothing really, you just stay the exact same shape and size and you'd move it up 2. But now it would look like this. What if you wanted to move it down 3? What if you wanted to move it to the right 2? Now, you might have to have a think about this, or you might have to mess around on GeoGebra in order to recognize this. I can do a video on this if you want me to make more sense of this part, but what actually happens if you want to move it to the right, you end up doing this. So if you want to move it to the right 2, x minus 2, move the 2 to the right. So it'll be the exact same size and shape as the original x squared function. Oops, it would just be 2 to the right. What happens if you wanted to move it 2 to the left, etc.? It would be x plus 2 to be squared. So when we start noticing our turning points here, 0, 0. And that's because, you didn't go up or down, you didn't go left or right. Therefore, you're at 0, 0 for your lowest point on your graph, your turning point. What you do here, you didn't go left or right, but you did go up 2. So that's your turning point. You did go right. You went 3 to the right. So plus 3. But you didn't go up or down. And this one's same. You went 2 to the left. No. Sorry. Okay. So this one, you went 3 to the right. Let's just do this in case. So if you wanted to go 2 to the left, it would be x plus 2 to be squared. I can't remember if I said a minute ago, did I go left or right? But anyway, that would be off over here at 2 to the left. Exact same size and shape. So turning point minus 2, 0. And eventually you kind of just go, right, if I have a function, then this helps tell me my turning point, because it'll tell me, did you go left or right? How many did you go left or right? Did you go up or down? How many, spots up or down did you go? So this is actually called completing the square format, and it allows you to pick out your turning points quite easily. Here, if you want to get into completing your square format, well, firstly, I started off and I took the 2 out in common. This isn't the most straightforward question, so there's much easier ones to do. So perhaps you might want to start off with a slightly easier one. Let's even just say x squared plus 6x plus 9. No, let's go for plus 6x plus 10, let's say. Okay, so you're going to look here and you see the coefficient is 1. That's grand, because it's the x squared that we're looking at. If there was something else, you'd have to take, if it was 2x squared, you'd take 2 out in common and then continue on. So this is why I'm starting off with maybe a little bit of a nicer one. You take the number here, you half it and you square it. So half of 6 is 3, 3 squared is 9. And I write that. Now, you can't just change the sum. So what do I need to do to this so that it's exactly the same as this? I'm going to add a 1. So now this and this are exactly the same thing. But when I factorize this, it turns into x plus 3 to be squared. So just take it to the side and factorize it, plus a 1. Now it's in completing the square format. This tells me that I went to the left 3 and up 1. So my turning point is minus 3, 1. You can do other ones just to see, maybe have a bit of practice because this one is not the most straightforward. Straight away, I'm taking a 2 out in common. Okay, it has to be x squared that I'm looking for. So I take the 2 out in common. Now, I'm not dividing by 2. It's not an equation. It's a function. So I take the 2 out in common. And I get this number here, and I half it, and I square it. So 3.5 halved is 7/4. And then square that, and you get a really awkward number, 49/16. Plus 49/16. Now that's also 3.020625. Now that's the same as that. That's the same as that. That's the same as that. But they're not the same, so I better subtract. What do I subtract, to get the -5 to be there? So I'm going to just write this down for a second. -31/16. I just want to check that. So -31/16 plus the 49/16 should give me a -5. Otherwise, I'm not right here. Oh, and it doesn't. Okay, so let me just try that again. So I have -5. -5 plus no, I keep doing the same wrong thing here. So that's not right. Sorry, no. So 3. What did I say? 49/16. My brain isn't working today. Okay, so I'm at 3.0625. And I want to be at minus that, so it needs to be -8.0625. So let's try that again. -8.0625. Yeah, okay, sorry. I had to do it in decimal, not fractions. Okay, why did I do that? Well, because I'm going to factorize this. So take it to the side and factorize it. Now, I only want this bit inside my bracket. As I said, this is a tricky one. I only want the x plus whatever the number is inside in the bracket. So what I'm going to do is, I still have 2 outside there. Or you could factorize first. But, so I have the 2 outside this, but I'm actually going to multiply it by the -8.25. So 2 bracket 8.0625 gives me 129/8. Minus 129/8. Okay. And then I want to factorize this. So take this bit to the side and factorize it. And when you factorize it, it just turns into 2 bracket. So this bit here, when you factorize it, is x minus 7/4 to be squared minus 129/8. Very awkward one, but I can still pick out my turning point. I went to the right, that amount, 1 3/4, and I went down that amount. I hope that makes sense. I would really start off with easier ones than this to do with completing the square rather than, this is a bit tricky. So if you want complete understanding, start with easier ones, then have a look at this one and try and work it out. Explain why f must have 2 real roots. Well, you have the option of just finding your real roots. That'll just show that you have 2 real roots. A bit faster than that is looking at your discriminant. And if your discriminant is, so b squared minus 4ac, if that's greater than 0, then you know that you have 2 real roots. So b squared minus 4 times a times c, that's 49 plus 80. That's definitely greater than 0. Therefore, I have 2 real roots. I suppose I can put greater than or equal to 0. It doesn't say they're distinct real roots, so I can do that. And then, last part, write your roots in this form. So now you're doing the whole minus b formula anyway, so you could have done it earlier on. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Throw that into the calculator, that's 7 plus square root of 129 over 4.